Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on measurements from March 2022, Paper 2. In this question, we will discuss especially about SI based units. We will discuss how to deal with SI based units. We will also do some other calculations about measurements. In this lesson, we are talking about Paper 2 from March 2022, and exam duration for this paper is 1 hour and 15 minutes, and total mark for this paper is 6. On second page of exam paper, you can find some important constants and their values. The first constant is acceleration of free fall, and its value is equal to 9.81 meters per second per second. You have to use 9.81 at AS level. You cannot use that. So you have to be very clear about this one. Next one is speed of light in free space. And this is also about equal to speed of light in air. It is also equal to speed of light in vacuum. Free space and vacuum are the same. So this is value of C. Next one is elementary charge. I mean, this is the smallest possible charge on any particle which can exist independently. So smallest charge is the charge on single electron, because electron is fundamental particle. Next one is atomic mass unit, and this is equal to 1.66 times 10 to negative 27 kg. Next one is rest mass of proton. Rest mass of proton simply means that when the proton is not moving or the speed of proton is very slow, so we can use this mass. At AS level, you don't need to worry about relativistic effects, so simply when you need to use mass of proton, you can use this value. Next one is rest mass of electron, and this is equal to 9.11 times 10 to negative 31 kgs. Same, rest mass means when electron is at rest, the speed of electron is quite slow as compared with speed of light. So then mass of electron is equal to this. Avogadro's constant. So here is value of Avogadro's constant. Next one is molar gas constant. You need to understand, maybe you need for some calculations, Boltzmann constant. So value of Boltzmann constant is given. Gravitational constant. You will need this one for A2. Maybe you will not need this one for AS physics. Permittivity of free space. Maybe you will not need for AS level, but you will need this for A2 physics. Next one is Planck's constant. This is also required for A2 physics. Last one is Stephen-Boltzmann constant. This is also part of A2 physics. On third page of exam paper, you can also find some important formulae. Let's try to understand some important points about use of these formulae. The first thing you need to understand here, this S. This is not the distance. This S is representing, in fact, displacement. So you have to be very clear. This is displacement. This is not the distance. Distance and displacement are equal when the body is moving in a straight line. If the body is not moving in a straight line, then distance and displacement, they are not equal. Displacement is equal to distance only if the body is moving in a straight line and direction of body is not changing. Body just move in one straight line in one direction. Then distance and displacement, they are equal. Otherwise, they are not equal. The second thing you need to understand is about A. In this formula, A is uniform, means A is constant. So you can use this formula only if A is constant. So A is uniform acceleration, means A has only one value. A is not changing with time. So if you want to use these two formulae, you can only use them if acceleration is uniform. Otherwise, you cannot use them. U here is representing initial velocity. So we can say U is initial velocity. V here is representing final velocity. So V is final velocity. If you go to next formula, this is about hydrostatic pressure, delta T, and this is delta H. So this is the change in depth. So you have to be very clear. What is delta H? This is change in depth. And rho here, this is density of fluid. Or simply you can say density of liquid. So this is density of fluid. Next one is upthrust, very important one. V here, this is volume of fluid displaced, not volume of object. So this is volume of fluid displaced. Very important point. You have to be very clear about this one. Volume of fluid displaced. Now we need to understand when volume of fluid and volume of object, they are the same. So we will discuss two separate cases. First case, when object is fully submerged. So I will be writing here when object is fully submerged. Fully submerged simply means that, let's say we have this container and we place one object inside. Let's say object is here, is fully submerged. In this case, volume of fluid displaced is equal to volume of object. But when object is floating, you can understand simply from here. Let's say we have this liquid and object is floating. In this case, mean object is somewhere here. In this case, volume of fluid displaced and volume of object, they are not same. So you have to be very clear about this. V is the volume of fluid displaced. When you can use this one equal to volume of object if the object is fully submerged, that if the object is floating, object is not fully submerged, you cannot use volume of object here. And rho is density of fluid. So this is density of fluid. Rho is density of fluid. Next one is about Doppler effect for sound waves. Fs is the frequency of the source, v is the speed of waves, and vs is speed of source. If object is approaching, so we will discuss the first case, object is approaching. If the object is approaching, you can simply modify this formula. We can say in this case Fs v over v minus vs. But if the object is moving away, so we can write down here, object is moving away. If object is moving away, then observed frequency is equal to Fs. V means the speed of the wave divided by V plus Vs. You need to understand when to use negative sign, when to use positive sign. Next one is electric current. So N here, this is number density. I mean, this is the number of free electrons per unit volume. N here is number density. And V here is the drift speed. Simply we can say, actually this is drift velocity, better to say. So this is drift velocity. Number density means number of free electrons per unit volume. And next formula is about resistors in series. So this is you can use when resistors are connected in series. The last one is about resistors in parallel, when the resistors are connected in parallel. This is how you can calculate. For question number 1, it is given to us a sphere of radius 2.1 mm falls with terminal means constant velocity through a liquid as shown in figure 1.1. So you can see this sphere, this is falling at constant velocity and its direction is downwards. It is also given to us three forces act on the moving sphere. The weight of the sphere is given to us. Upthrust on the sphere is also given. It is also given to us viscous force Fv act on the sphere, and we can calculate Fv means the viscous force using this formula. In this formula, r is the radius of the sphere and v is the velocity. K is a constant and the value of k in SI units is 17. We need to determine SI base units of k. First of all, let's try to understand what are SI base units and why we call them SI base units. First thing we need to understand, these are SI base units because in System International, if you need to derive unit of any physical quantity, you can express unit of that physical quantity in terms of SI base unit. So means these units are the base of any other unit in SI system. Let's try to understand a little bit more about SI base quantities and SI base units. First quantity is length and its unit is meter. Next one is mass and its unit is kg. Next one is time and its unit is second. Then we have temperature and its SI base unit is Kelvin, not degree Kelvin. If you write in this form, this is wrong, is Kelvin. And the next one we have electric current. So simply we can write down electric current. And SI base unit of electric current is ampere. In physics, mostly means at this level, we will be focusing on these 5 SI quantities and SI base units. But we have 2 more. Next one is light intensity. or I can simply say intensity, light intensity, or you can say intensity. Light intensity, the unit of this one is candela. We use CD for this. And the last one is amount of substance. SI base quantity is amount of substance, and its SI base unit is mole, MOL. This is the symbol. So these 7 SI base units we can use to express unit of any other physical quantity in terms of these units. So that's the reason we call them SI base units. Now let's try to answer this question. We need to find SI base unit of K. For K, it is given to us that FV, this is equal to KRV. From here simply we can write down K is equal to FV over RV. For force, first of all, we can write down SI base units. Force is equal to MA. So the SI base units for force are kg meter per second. And we can also write down SI base unit for R. Radius, SI base unit is meter. And for velocity, we can also write down SI base unit. That is meter per second. Now simply we need to plug in here. For force, we can write down this is kg meter per second, and this is divided by meter, and here we have meter per second. Now we can simplify this meter we can cancel with this meter. Now we can write down this is kg per meter, and here we have per second. So this is SI base unit of K. This question has 2 marks. The first mark you will get if you have written SI base unit for the force, and that is C1 mark. If you have written this one, you will get 1 mark. And the second mark is the answer mark. If you have got the right answer, you will get second mark. But if your answer is right, you haven't written this step, still you will get 2 marks. For part B, question is asking us to use the value of the upthrust acting on the sphere to calculate the density of the liquid. But value of upthrust is given. If you read question carefully, it is given to us upthrust is equal to 4.8 times 10 to negative 4. Simply we can say upthrust is given to us, and this one is equal to 4.8 times 10 to negative 4 newtons. Radius of the sphere is also given, so we can also calculate volume of the sphere. Volume is equal to 4 by 3 pi r cube. So we can plug in values here. This is 4 by 3 pi r cube, but r is given in millimeters, so we have to convert this one into SI units. So this is 2.1 times 10 to negative 3 cube of this quantity, means cube of radius. Density of the fluid. Density of the fluid we need to find out. So first thing, now we need to understand upthrust, this is equal to density of fluid times G times volume of fluid displaced. But in this case, our object is fully submerged. It means the volume of the fluid displaced. This is volume of fluid displaced. This is equal to volume of object. So we can say volume of fluid displaced is equal to volume of object. Why? Because object is fully submerged. So we can also write down object is fully submerged. Now simply we need to use formula and we can find out value of density. So if we rearrange this equation, we can simply write down density of fluid is equal to upthrust divided by G times volume of object. Upthrust, we have the value of upthrust is 4.8 times 10 to negative 4 divided by G, that is equal to 9.81, and we have volume that is equal to 4 over 3 pi r cube, that is 2.1 times 10 to negative 3 cube of this. Now simply we need to solve this. If we solve this one, we can get value of density, and in this case value of density up to 2 SF, this is equal to 1300 kilograms per cubic meter, means up to 2 SF. Why do we need to use 2 SF? If you look at the raw data, means given data, this has 2 SF, so this has 2 SF, and this one has 3 SF, this one has 2 SF. So our final answer, we use least number of SF. least number of SF in raw data. Least number of SF, simply I can say, in given data. That's the reason in our final answer we are using 2SF, because in the given data least number of SF is 2SF. So this is also 2SF and this is 3SF. So our final answer as 2SF equal to least number of SF in given data. So our final answer for this question is 1300 kilograms per cubic meter. You also need to keep an eye on the given units. So our answer has to be in SI base units in this case. So this is our final answer. You will have 3 marks in total. The first mark you will get if you have calculated volume. So you will get first C mark. And the second C mark you will get if you have rearranged this formula to calculate density. So this is second C mark. And the final mark is answer mark if you have got the right answer. That if your answer is wrong, you have written these 2 steps, still you will get 2 marks. For part C1 on the sphere in figure 1.1, we need to draw 3 arrows to show directions of the weight, upthrust, and the viscous force. Label these arrows W, U, and FV respectively. It means for weight we have to use symbol W, for upthrust we have to use U, and for viscous force we have to use FV. Now if you look at this sphere, the weight means the force of gravity is always acting downwards. It doesn't matter sphere is moving or not. So this is direction of W. Weight is acting down. Upthrust always acts upwards. It doesn't matter sphere is moving or it is at rest. So this is direction of upthrust, means upthrust is acting upwards. Now we need to understand what is direction of viscous force. Direction of viscous force, it depends on direction of motion. In this case, sphere is moving downwards. It means viscous force is acting in opposite direction. So the viscous force has to be acting upwards. So this one we can simply say this is FV. So this is direction of viscous force. This is all what we need to do for part 1. And if you have drawn these arrows, you will get 1 mark. This part has only 1 mark. For the second part, we need to determine the magnitude of the terminal velocity of the sphere. Terminal velocity means the constant velocity. If the velocity of this sphere is constant, it simply means that the resultant force acting on this sphere is equal to 0. Now, in this case, you can see the downward force is weight. So, in this case, weight is equal to upthrust plus FV, means the viscous force. Upthrust plus viscous force, I'm just writing FV, viscous force. If we have value of viscous force, then we can find out the value of V. So if we rearrange this one, we can write down FV is equal to weight minus upthrust. But for this question, we have value of the weight. Weight of the sphere is given, so this is value of the weight. Weight is equal to 7.2 times 10 to negative 4, and value of upthrust is also given in this question, and that is equal to 4.8 times 10 to negative 4. And from here we can find value of viscous force FV. If we solve this one, our answer in this case will be 2.4 times 10 to negative 4 newtons. So this is value of FV. In this question, it is also given to us that FV, this is equal to K times V times R. And V is the terminal velocity. I mean, this is VT. This is what we need to find out. So simply we can rearrange. So VT in this case will be equal to FV divided by K times R. FV, we have the value of FV, that is equal to 2.4 times 10 to negative 4. And value of K for this question is also given, that is equal to 17. K is a constant, its value is equal to 17. R is the radius, and radius of the sphere in this question is given, that is equal to 2.1 mm. So simply we can write down 2.1 in SI base units, 2.1 times 10 to negative 3 meters. Now simply we need to solve this one and we can find out value of velocity. So in this case, if we simply plug in values, we will get 6.7. So this is 6.7 times 10 to negative 3 meters per second. So this is value of terminal velocity. And this question has 2 marks. The first mark you will get if you have got the right value of Fv. So this is first C mark. And this is the answer mark. If you have got the right answer, you'll get this mark. But if your answer is wrong, but you have written this step, still you will get 1 mark.